Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrunner, and today we're talking about circuits. Specifically, we're talking about Ohm's Law. Ohm's Law states the relationship between a DC voltage across a resistance and the DC current through the resistance. So for Ohm's Law, we write V is equal to R times I. This means that the voltage is equal to the resistance times the current. In other words, the voltage and the current are proportional. Usually I suggest that students try to remember V is equal to IR because that spells the word ver. Let's consider an example. Suppose we have a simple circuit that has a voltage source of 10 volts and a resistance of 2 ohms. I've drawn this circuit with curved lines just to point out that the square corners that we usually use when we write circuits are just for a convenience for drawing. So normally we would just draw this circuit. Let me just go ahead and draw it with the square corners that would be typical. Okay, I just want you to know that that's not important. Okay, so let's go ahead. Now, suppose we want to know the voltage across this resistance. Well, we know that the voltage across the resistance is going to be the same as the voltage here, right? This line is connected to this line is connected to this line. In other words, they're the same point. We always assume that the lines that we draw are equivalent to wires with no resistance. So we have this voltage we know is going to be equal to 10 volts. Okay? Suppose we want to know the current going through that resistor. Okay? To find the current going through the resistor, we use Ohm's Law, which tells us V is equal to I times R. We know that voltage is 10 volts. We know the resistance is 2 ohms. And so that tells us that the current is going to be 10 volts divided by 2 ohms, which is equal to 5 amps. Volts divided by ohms is equal to amps. Now, what I've done is apply this Ohm's Law equation very simply, but I've kind of glossed over the important part about how the signs are defined. Okay, so we'll define, for Ohm's Law, we define the voltage and the current so that the current enters that positive voltage. Okay, that's just how we define it. And so it works. Now we could have defined our voltage the other way. Okay, let's consider the example again. We still have the same circuit, 10 volts. We still have a 2 ohm resistor. But now suppose I want to talk about the voltage from here to here, which I'll call V prime, just to give it another name. And I want to talk to about the current going through the resistor going in that direction. So again, I have defined the current going into the plus side of the voltage. And I'm going to call this current I prime. So now we can write V prime is equal to I prime times R. So what is V prime? We know that V prime is going to be the voltage from here to here, which is the same as the voltage from here to here. And so that's going to be minus 10 volts. Okay, notice that the sign actually tells you the direction of the voltage. Okay, so now let's use Ohm's Law. Again, we've defined our voltage and our current so that the current is entering the positive side of the voltage. So we have V prime is equal to I prime R, and that gives us minus 10 volts is equal to I prime times R, which is 2 ohms. So I prime now is equal to minus 10 volts over 2 ohms, which gives us minus 5 amps. In other words, the voltage we know is actually positive from here to here. So we got a negative voltage when we defined V prime. Similarly, we know that in reality, the current is flowing down through that resistor. Down, of course, is a feature of our drawing, but it's flowing in that direction through the resistor. And so when we calculate I prime, what we end up with is a negative value. So when you have a negative value, all that means is that the direction you assumed was wrong. Now, this does not matter at all. In fact, what it lets us do is it lets us be free of trying to figure out the direction of the current and the direction of the voltage. By doing this, we just have a negative current if we pick the wrong direction, and everything will work out in the end. Now, let's consider an example. So what I have shown here is a circuit with a battery. Okay, a battery is just a special kind of a voltage source. For our analysis, we will use them interchangeably, but I wanted to make sure that you saw it here. And in this voltage source, this battery, I've got the voltage defined from plus to minus. Okay, so the plus is going to be on the long side, and the minus is on the short side. That's just how the symbol is represented. Okay, so here's a circuit with the voltage from here to here being plus 12 volts, and we want to find the current IR that goes through that 6 ohm resistor. Now we know that Ohm's law says that V is equal to IR, so we will use that. But in order to do that, we need to know what the voltage is. Okay, so the voltage from here to here, which is how Ohm's law is defined, right? Ohm's law is defined as the current going into the positive side of the voltage. So if I define that voltage plus minus and I call it VR, then we know that VR is going to be equal to minus 12 volts. And that's because the minus here is connected to the plus here, and the plus is connected to the minus. It's the opposite direction as the voltage across the battery. So we also know that R is equal to 6 ohms. And now we can solve for VR equal IR times R. Okay, so IR will be defined to be VR over R, which will be equal to minus 12 volts over 6 ohms, which gives us minus 2. And volts divided by ohms gives us amps. So IR is minus 2 amps, and that is our answer.